Welcome, geometry student, to the homework up video, page 403. Let's go ahead and get started with the problems. Numbers 7, 8, and 9. The directions say to state the postulate or theorem that can be used to prove that the two triangles are similar. Well, obviously, this one's going to be angle, angle, okay? Because if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. And of course, we call that the angle postulate, okay? Alright, and by the way, you could have circled other angles, not just these two here. Number 8. Alright, let's see what we have here, students. The smallest side is 5, and the smallest side over here is 2.5. The next smallest side is 6, and the next smallest side over here is 3. And then 7 is the longest side, and it goes over the longest side over here, 3.5. Now, let's reduce all of these and see if we get equal fractions, okay? 6 over 3, of course, is 2 over 1. If you divide, let's see, and I do know how to do this. I'm just trying to think of the easiest way to explain it. I don't want this decimal here, so I'm going to move that decimal one place so that it's gone. But if I move this decimal one place, I must also move the top decimal one place, so it gives me 50. So 5 over 2.5 is the exact same thing as 50 over 25, okay? And if you reduce 50 over 25, you get 2 over 1. Now, same thing here. I don't want this decimal. I can move it one place as long as I move the top decimal one place also. So I have 70 over 35, which is the exact same thing as 7 over 3.5. If you reduce this, you get 2 over 1. So look at that. All three ratios are equal. So that means all of the sides are proportional. So we have side, side, side theorem. Remember, if three sides of one triangle are proportional to the other corresponding three sides of the other triangle, then the two triangles are similar. Okay? Alright, number 9. Well, here we go. We have a side, angle, side. We have a side, angle, side, and the angles are congruent. So, if that included angle is congruent, which it is, the only thing left is to have proportional sides. So my smallest out of these two is 6, and my smallest over here is 9. So 6 over 9 equals 8 over 12. Let's reduce this and you get 2/3. Let's reduce this and we get 2/3. So, let's see if everything lines up. We have two sides and an included angle, two sides and an included angle, and the angle is congruent, and the sides are proportional. Well, that's called side, angle, side. Remember that theorem? Anytime you have an angle of one triangle congruent to an angle in another triangle, and the two sides of that included angle are proportional to the two sides of the other congruent angle, then the two triangles are similar. Okay, not too bad. Okay, numbers 10, 11. The directions say to decide whether triangle ABC is similar to triangle DEF. Okay, so let's first of all start off comparing ABC to letter A. Okay, so I have 3 over 1, 3 to 1, 3 to 1, 6 to 2. So 3 over 1, 3 over 1, 6 over 2. If you reduce 6 over 2, you get 3 over 1. All three fractions are equal, so this would be yes. Alright, let's try the next one, okay? We have 3 over 6, 3 over 6, 6 over 9. If you reduce all three fractions, you get 1/2, 1/2, 2/3. Are all three fractions congruent? Not at all. So this triangle here is not congruent to this triangle here. And now let's compare ABC to this triangle over here. So we have 3 over 4, and then 3 over 4, and then 6 over 8. If you reduce 6 over 8, you get 3/4. So I have 3 congruent fractions. That means these sides here are proportional to these sides over here. So yes, the two triangles are similar. Number 11, same thing again. So here we go. 4/2, 4/2, 8/4, 10/5. And obviously you get 2/1, 2/1, 2/1. So yes, this triangle here is similar to this triangle here. Yes. Alright, let's take a look at letter B here. 4/6, 8/12, 10/15. Well guys, right away we can see, I think this looks pretty good. 4/6 reduces to 2/3. 8/12 reduces to 2/3. And 10/15 reduces to 2/3. So do we get out 3 congruent triangles? Yes, we do. So yes, we definitely have similar triangles. And then lastly, 4/6, 8/10, 10/12. Well, guys, we can just stop right there. Look, 4/6 reduces to what? 2/3. And 10/12, that's going to reduce to 5/6. So there's no way all 3 triangles or all 3 fractions are going to be equal, okay? So, no, triangle C here is not similar to triangle ABC. Alright, okay, moving on to numbers 12 through 15. The directions say to roughly draw the triangles and then name the postulat or theorem that can be used to prove the triangles are similar, okay? Now, in the directions, they tell you this right here. They tell you that we have triangle PQR and triangle XYZ. Okay. Now, I'm not going to try to draw these to scale like it said to. I'm just going to put PQR X, Y, Z, okay? And I think we'll use these over and over for our next problems too. Alright, here we go. Okay, so let's see what we got here. PR is 14. PQ is 12. QR is 6. XC is 7. XY is 6. YZ is 3. Now students, how do I know these 2 triangles are similar? Well, it's probably going to be the side theorem, I would think, but let's make sure. Smallest side is 6. Smallest side is 3. Next smallest side is 12. Next smallest side down here is 6. Largest side or longest side is 14. Longest side down here is 7. If you reduce all these, you get 2/1, 2/1, 2/1. And they're all equal. So, what theorem would I use? Side. If 3 sides of one triangle are proportional to 3 sides of another triangle, then the 2 triangles are similar. Number 13. Okay, students, number 13, here we go. Alright, let's use these same triangles here real quick. And let's see what we got. PR is 15. Angle P is 70 degrees. PQ is 21. XC is 5. Angle X is 70 degrees. XY is 7. Now students, it looks like we have side, angle, side. First of all, make sure your included angles are congruent. Yes, they are. Secondly, make sure your sides are proportional. So biggest side would be 21 over biggest side down here is 7 equals next biggest side 15 over next biggest side would be 5. And if you reduce both those fractions, you get 3/1. So yes, my included angles are congruent, and yes, my sides are proportional. So you would use the side angle side theorem to state that these 2 triangles are similar. Alright, number 14. And here we go. Alright, let's see, the measure of angle R is 15 degrees. The measure of angle P is 75 degrees. The measure of angle Z is 15 degrees, and the measure of angle X is 75 degrees. Well, it's obvious we're going to use the angle postulate. If two angles of one triangle are congruent to two angles in another triangle, then the two triangles are similar. Pretty simple, guys. Moving on to number 15. Here we go. Now, we're dealing with, be careful here, we're dealing with PQ over XY, got it, equals 4, and QR over YZ equals 4, okay? So, right away, listen to me, we know this side here, this side here, this side here, and this side here are what? Proportional. Guys, we know that for sure because this side over this side gave you 4, and this side over this side, when you reduced it, gave you 4 also. Now all that we need are included angles. That would be Q and Y. Well, look, angle Q is 25 degrees. Angle Y is 25 degrees. So we've got side, angle, side. We have an included angle that's congruent to an included angle over here, and the sides are proportional. Okay? Alright, moving on to numbers 16 and 17. Now, the directions just simply want us to set up the proof and then lay out a plan of attack, but we're not going to actually do the proofs, okay? So, two right triangles are similar if the lengths of corresponding legs are proportional, okay? So, let's see if we can figure out what our if part is and what our then part is and all of that good stuff. Let's see. Okay, here we go. If, I'm going to reword this. If corresponding legs of right triangles are proportional, okay? So if corresponding legs of a right triangle are proportional, then they are similar, okay? So if the corresponding legs of two right triangles are proportional, then they are similar. Well, let's write out our if part, our given. And actually, before we write out our given part, we probably should draw some quick pictures. So here's a right triangle, and here's another right triangle. Okay, there we go. And we are going to state that the two sides, the two legs are proportional. So I'm going to call this, I don't know, call this 5, and we'll call this 10, and we'll call this 2, and we'll call this 4, okay? Now, so you're given, okay, you were given that, AB over DE equals BC over EF. That's what you're given. And you're also given that triangles A, B, C, and D, E, F are what kind of triangles? Right triangles. Okay? Now that's what you're given. You're given two right triangles. And you're given the fact that the sides are proportional. So you're going to prove that triangle ABC is similar to triangle DEF. Okay, so quickly get rid of all this stuff here. And let's see if we can't lay out a plan of attack, okay? And what's that there? Is that D? Alright. Alright, now, is so simple, guys. All you'd want to do is state that angles B and E are what type of angles? Right angles. Then you'd want to state that angle B is congruent to angle what? Angle E. And then you're all done, because you're already given that the sides are proportional. That was given to you right up here. The corresponding legs are proportional. All you have to do is prove that this angle here is congruent to this angle here, and now you can state that the two triangles are congruent by side, angle, side. Do you see that? In the given, they already told us the sides are proportional. All that we had to do was prove that these included angles were congruent, and we have side, angle, side, okay? Alright, number 17. We did one like this already in a previous lesson. I'll do it again real quick. Two isosceles triangles are similar if the vertex of one is congruent to the vertex of the other. Well, students, look. I mean, again, it's pretty simple. There's an isosceles triangle. Here's a bigger one. And let's call this angle here congruent to this angle here. Triangle A, B, C, D, E, F. Okay. So my if part is if the vertex angles of two isosceles triangles are congruent, then they're similar. They kind of word these difficult, so try to look at this carefully and see if you can follow what I'm doing here. Okay, two isosceles triangles are similar, so they're telling us they're similar if, and if is always your given part. So if the vertex of one is congruent to the vertex of the other, so your given part is triangles A, B, C, and D, E, F are isosceles. Okay, and angle B is congruent to angle E. So, that's what's given to us. Students, I hope this is making sense. Please pay close attention, okay? And we're going to prove that triangle ABC is similar to triangle DEF. Now, students, look what you're given. You are given these angles are congruent, correct? Now, here's your plan of attack. You know, watch, this is so cool. You know that AB's congruent to BC, right? Because it's an isosceles triangle. And you know that DE is congruent to what? EF, correct? Now, the division property states that we can divide this side here by anything as long as we do the same thing to the other side. So I'm going to divide AB by DE. But if I do that to one side, I must do it to the other side. Okay, no problem. There. Now, what can I substitute for DE? DE is congruent to EF. So now put EF for this. And students, look what you have. You've got AB over DE equals BC over EF. So that would be your plan of attack. I mean, we already know the angles are congruent. They told us that in the given. All that we had to do was prove that the sides are proportional, and we just did it. We just proved the sides are proportional, so we're good. That's how you would attack this proof, okay? Alright, these are not easy, so I hope you're getting this. Alright, number 18. Now, to determine the height of the model, of course, if you read the instruction or the directions, it says you visit King's Dominion Amusement Park in Doswell, Virginia. The park has a scale model of the Eiffel Tower. The scale factor is 1 to 3. Excuse me for yawning. Okay, now you place a mirror on the ground and stand where you can see the top of the tower as shown below. How tall is the model? Well, look, guys, draw some triangles here. Look, this is a right triangle right here. Unless the guy's like leaning over, or he's, a hunchback or something, okay? And this triangle here is a right triangle, okay? So I've got a right angle here, I've got a right angle here. They tell you these angles are congruent. Students, you have two angles in this triangle congruent to two angles in this triangle. That means they're what? Similar. Anytime two angles in one triangle are congruent to two angles in another triangle, the triangles are similar. So they want you to find the height, how tall is the model, we'll call this x. So I can say 5.5, which is the height of this, over x. So 5.5 over x equals 0.5, the length of this, over 30. So 0.5 over 30. Now here we go. Let's go ahead and cross multiply. So 0.5 times x is 0.5x. And 5.5 times 30 would be, let's see, 165. Now divide both sides by 0.5 and you will get 330. So now you know the height of this model Eiffel Tower located in Virginia, 330. I'm not sure why I put degrees. 330 feet. Got it. Now, look at question 19. If the model's 330 feet, then how tall is the real actual Eiffel Tower? Well, think about it. The model we just looked at is how tall? Do you remember? 330 feet. Alright. Now, they told you, if you look at the directions, before number 18, if you look at the directions, it says the scale is 1 to 3. That's the scale, 1 to 3. So that means you're going to multiply this by 3. For every one of these, they have 3 of the Eiffel Towers. So if the model's 330, multiply that by 3, and you get 990 feet. Now, if you're confused about what I did, just look at it like this, okay? Your ratio is 1 to 3, right? So 1 over 3. Of course, 1 is the smaller Eiffel Tower, the model, and your model's 330. So 1 over 3 equals 330 over x. Cross multiply, 990 equals 1 times x is x. 990 equals x. So the real height of the Eiffel Tower is 990. Okay, moving on to numbers 22 through 25. The directions say to solve for x, okay? So here we go. Now students, please listen to me carefully, watch this. I have two parallel lines cut by a transversal. Corresponding angles are congruent, so this angle is congruent to this angle. Then I have parallel lines cut by a transversal, and we learned that when two parallel lines are cut by a transversal, corresponding angles are congruent. So these angles here are congruent. So I showed you all of that to now show you this. Put this here and put this here. Okay, now I'm going to put the smaller triangle here. X and 3. Now I'm going to put the bigger triangle down here. All the way across is 8, and all the way up here is 8 also. From here to here is 5, from here to here is 3, so 8. So, let's find now the two triangles are definitely similar. How do I know they're similar? Because if two angles in one triangle are congruent to two angles in another triangle, then the triangles are congruent. So, 3 over 8. 3 over 8 equals x over 8. Obviously, x is going to be 3. 3 times 8 is 24. 8 times x is 8x. Divide by 8. And 3 equals x. Alright? Okay, number 23. Alright, same thing, guys. Now look, I've got parallel lines, okay? So, here's my parallel line right here. Parallel lines cut by a transversal right here, okay? So this angle here is congruent to this angle here. Parallel lines cut by a transversal. And really, that's all that I need because I have a right angle already, so I'm going to stop there. And I'm going to mark this angle here congruent to this angle here. Now let's draw the smaller, the smaller right triangle. It always helps if you pull them apart, students. From here this angle here is congruent to this angle here. This whole length here is 8, and this whole length here would be 4. From here to here is 3, from here to here is 1, 3 plus 1 is 4. Now, let's solve for x. Are the two triangles similar? Of course they are. How do I know that? Because if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. So with that in mind, here we go. 3 over 4 equals x over 8. 4 times x is 4x. 3 times 8 is 24. Divide by 4. X equals 6. Alright, number 24. Okay, here we go again, guys. I mean, pretty much the same thing. Look, parallel lines cut by a transversal. Corresponding angles are congruent. Corresponding angles. So, I know that I'm going to have a right angle here. Let's go ahead and draw my smaller triangle. Length is x right here, 3. Put a congruent symbol right here. Now let's draw the bigger right triangle. Okay, right angle here. Congruent symbol right here. And let's see, this whole length here would be 5. Right here. Now, students, I was getting ready to draw my proportions and I realized I didn't know enough sides over here, so it kind of stumped me for a second. But look, anytime a big triangle like this, anytime you have a triangle, now watch, with congruent angles, two congruent angles, their opposite sides are congruent. So, now watch this carefully, okay? So, because I have two congruent angles here, forget this line, pretend that line's not even there just for a second, okay? I've got this triangle here that has congruent angles, so that means the opposite sides are congruent. That means this whole side here is 5. That means this whole side here has to be 5 also, which means this little space from here to here is 2. So the whole side's 5. So I'll put a 5 here, okay? And now we're ready, okay? Now notice this 3 right here. Now look, guys, see this 3? It's along the side that has a right angle and a 1 mark angle. So what side has a right angle and a 1 mark angle? This side. So 3 over 5 equals x over 5. And of course the answer will be 3. 5x equals 15. Divide by 5 and x equals 3. Okay, moving on to number 25. And let's see what we have here, okay? Okay, students, first of all, we have congruent sides here, congruent lengths. So if this is 2, this is also 2 here. Also, parallel lines. So this angle here would be congruent to this angle here. Parallel lines cut by a transversal. Same thing here. These two angles here would be congruent to these two angles here. So I have one triangle. I'm going to trace it here real quick. I have one triangle that looks like this. Then I have the other triangle that looks like this. And we'll put that here. Now let's mark some things. This is a length of 2. This whole side here is a length of 4. This line here is the length of x. I have an angle here congruent to this angle here. I have this angle here congruent to this angle here. And this whole length here is 10. Now first of all, as soon as we realize we have two angles in one triangle congruent to two angles in another, we know these two triangles are similar. Next, I can say 2 over 4 equals x over 10. And now we're all set. 4 times x is 4x. 2 times 10 is 20. Divide both sides by 2. And x equals 5. Okay, x equals 5. Okay, moving on to numbers 26 through 20. 26 through 29. Find the distance labeled x. So here we go. Again, it's getting pretty redundant. Pretty simple here, guys. Once again, we have similar triangles. This little triangle here is going to be similar to the big triangle here, okay? So let's go ahead and quickly draw that. Here's the big triangle here. Here's the little triangle here. And so I have a right angle here, a right angle here. This is x. This is 25, 10 plus 15. This is 15, and this is 15. Okay, now how do I know the triangles are congruent? Well, first of all, they share an angle. So this angle here has to be congruent to this angle here. The two triangles share this angle, plus they both have a right angle. So if two angles in one triangle are congruent to two angles in another triangle, then the two triangles are similar. And now I can state that x over 15 equals 25 over 15. Alright, and so x should equal 25. Just trust me on this. I'm going to save time. If you were to cross multiply and then divide, you would get 25. Okay. All right. Moving on to number 27. All right. Now look what we have here, students. We have a triangle here and a triangle over here. And notice this angle here has to be congruent to this angle here because they're vertical angles. So really, students, here's what I have. Okay, watch carefully. Here's one triangle. Now let's see. This has a length of x. This has a length of 14. This has a length of 5. A length of 7. And I know this angle here is congruent to this angle here. This angle here is congruent to this angle here. So I have two angles in one triangle congruent to two angles in another, so the two triangles are similar. Now be very careful when you match up your sides. See, this x is on the side here that has 1 mark and 2 marks. So x over, here's the side here that has 1 mark and 2 marks, 5. So x over 5 equals 14 over, this is the side that has 1 mark and nothing else, and the 7 has 1 mark and nothing else, so 14 over 7. If you cross multiply and divide, you will get, let's see here, you will get, I believe, 10, is that right? Let's see, 60, 5 times 14 is 70, 7 times x is 7x, divide both sides by 7, and 10 equals x. Okay, moving on to number 28. Okay, same thing again, guys. So we have two triangles. Here's the smaller triangle right here. There we go. Now let's see, right angle here, right angle here. Both triangles shared an angle up here. So mark this, and let's see, going across here, the whole triangle is 125. This one here would be 100. This whole length right here would be 20 plus x. From here to here's x, and then from here to here's 20. So x plus 20, and then this length from here to here is just x. So this would be x right over here. So here we go. X over x plus 20. Because x has 1 mark in the right angle, and x plus 20 has 1 mark in the right angle. 100 has the right angle, nothing else. Right angle, nothing else. So x over x plus 20 equals 100 over 125, okay? Now let's very quickly reduce this and make it a lot easier. This would be 4/5, okay? Let's just reduce it and make it easier. Alright, now 4 times x plus 20 would be 4x plus 80. X plus 5 would be 5x. Bring make it a negative 4x. And you're left with 80 equals 1x or x. So the answer is 80 for number 28. And then lastly, finally, number 29. Let's see what we have here. We have a little triangle right here. And then we have a big triangle right here. And let's label as much as we can real quick here. Let's see, all the way up is 80, so I'll put 80 here. From here to here is 30, so I'll put a 30 here. All the way across the bottom, big triangle is 48. This is a right angle here. This is a right angle here. This is x right here. Now notice both triangles are sharing this angle up here. So this angle here is congruent to this angle here, okay? So if two angles in one triangle are congruent to two angles in another, then the two triangles are similar. So here we go. I would say 30 over 80, because 30 has no mark and 1 mark. 80 has 1 mark and no mark. So 30 over 80 equals x over 48. Now, real quick, I would reduce this fraction. I would use 3/8, okay? Makes it a lot easier. 8 times x is 8x, and 3 times 48 would be 24. Carry your 2, 144. Alright? And then divide both sides by 8, and you should get 18, I believe. Yes, 18. Okay? So there we go, guys. Alright, I hope this homework help video has been a help to you. If you have any questions, don't hesitate to call or email.